Hi everyone, my name is Alexei and welcome to my channel. I'm a software engineer working in Bay Area, and in the last couple of years I interviewed with multiple companies and got offers from most of them. I solved a good number of lead code problems to prepare for interviews, and I'm still solving them even now when I'm not looking to change my job anymore. I created this channel to share my interview experience and to talk about problems asked during interview loops with tech companies. So you can have another video among many others to prepare for your interview. We would not be limited to just solving problems. In the future, I will invite software engineers and managers where we can talk about software engineering in general. So if you want to hear discussion on a particular topic, let me know in the comment section. Now, let's just get into today's topic. Today is the first video, and just to warm up, we are going to have a look at an easy problem that I've been asked during the first interview stage with the EV company. Even though this problem is easy, you should not extrapolate it to the whole interview experience. The next stages that I have were focused on a graph and C++ understanding. But as in a real interview, we are going to start with something that we can easily digest. Also today, we will use the lead code as our platform to solve this problem, and I will attach the link so you can practice on your own. With this being said, let's just jump into the problem. The first problem would be to find a string in another string. Let's have a look at the examples. We have a high stack, set but set, and we have a needle, set. We want to check if needle exists in the high stack, and if so, we want to return an index where it starts. Sounds easy, right? The algorithm is actually straightforward. We iterate through the high stack and check if the characters of both strings match. If they are, we are going to compare the rest of the characters, and if not, we are going to continue to the next character. So let's implement that quickly. We're going to iterate through the high stack. Through the high stack minus the size of the needle. And the reason for that is because we are going to have another function match, which will accept the index in the high stack and the needle itself. And if the needle is inside the high stack, then we're going to return the index of the first occurrence of needle in the high stack. Otherwise, we're going to return false. Now let's implement the match function. The match will accept the index in the high stack and the needle. Now we are iterating through the needle and we are comparing the index at needle with the high stack at index plus I. And if the characters are not the same, we're going to return false. If we're iterating through the whole needle and the high stack and all the characters are the same, then we are returning true. Then the match, if the match returns true, then the whole function will return the index of the first occurrence. Otherwise, I think we need to return -1 if there is no match found. Then let's run that. And we have a runtime error. Let's have a look at the test case. So the test case is the needle size is greater than the high stack size. And it leads to runtime error because I'm subtracting the needle size, which has a greater size than the high stack. And then that leads to the very huge number here, and the I will ultimately become huge enough to lead to the runtime error. So then we need to convert the size to integer, so the subtraction here can be negative, and we are not going to enter the for loop. Let's run again. Okay, then we have another failure, and we have a needle A, B, C, D, and we were not able to find the solution is because the A, B, C, D is at the end of the high stack. So, and I think we're not going far enough to find that answer. So we need to change the operator here to less than equal. Let's run again. Okay, then let's submit. Nice. Now let's just think about the complexity of this problem. In the worst case scenario, it's big of n by m. And I would say that this implementation should be enough at the first stage of the interview. The hiring managers probably just want to make sure that you can code and want to see how you approach problems and ultimately decide if they want to proceed with the full interview loop with you. However, there is a nice algorithm that exists which allows us to achieve linear time complexity, and this is really what this video is about. The Knuth-Morris-Pratt algorithm is what we want to discuss here. If you have a look at our code, we see that every time we fail to find an answer, we restart from the next character. And sometimes this can be inefficient. So let's quickly have a look at example. Let's add a test case here. And the test case will be the haystack is ABC, ABC, ABD, and the needle is ABC, ABD. So in the original approach, we are comparing from the beginning of the haystack and needle, and we see that the first attempt of comparison would almost succeed. Almost all characters except the last one are the same. So we see that ABC, AB is the same, and then the C is not the same as the D. Let's see if we can exploit the information in the needle to improve the algorithm. If we have a look at the needle, we see there is a slight pattern here. We see that the needle is ABC, ABD. We see that when we fail to compare the character D with the character C in the haystack, we know that before the character D there is an AB substring, and that AB substring is actually a suffix of the needle, and it's also a prefix of the needle. This means when we find a mismatch between the last character in needle and the C character in the haystack, we can still continue our comparison from the current character in the haystack and the next character after the prefix in the needle. But note that when we find a mismatch between D in a needle and C in a haystack, we cannot just disregard that information and continue our comparison after the C with the needle, because in this case we would fail to find a comparison. So we need to use information that we know about the needle to optimize our solution and to be able to find the final answer. Okay, now let's reset the code editor. Let's go to the description and implement the approach that we just discussed. So the first thing that we want to do is that we want to compare the needle size with the haystack size. And if the needle is higher, the size of the needle is higher than the haystack, we want to return -1. Because we couldn't find any solution in this case. Now, we talked about that we want to build additional context from the needle to optimize our solution when we iterate through the haystack. So now we want to build that context. And that context would be represented by the PS array. The PS array will have the same size as the needle, and they would fill with the zeros originally. Now we're going to iterate through the needle starting from position 1, and we will have two counters. One with the starting from the position 1 and another one starting from just the beginning of the needle. Now we want to fill the PS array with the length of the substring that is the prefix and also a suffix. So what it basically means is that we're going to increment the J when the needle at current position is equal to the needle at the beginning position. And if that's the case, we're incrementing the J and we place that in the PS under the index I. But now what will happen if there is a mismatch? If there is a mismatch, we want to reset the J. So if the J is not equal to 0, let's say that we found some subarray which is also suffix and prefix, but the next character after that doesn't equal to the next character after the prefix, then we want to reset it to the closest substring length. So, and in order to reset this, we are going to have a look at the previous lengths of the needle, and then we're going to compare it with the current character. And if they're not equal, we're going to continue the process. If they're equal, we stop, and then we continue the filling the PS array. Okay, now we want to continue our implementation, and now we're iterating through the haystack, and we're also iterating through the needle, so we need two pointers, indices. And then while the index I is less than haystack size, we're gonna continue the process. And the actual implementation is almost identical to how we fill the PS array, which is basically the context based on the needle. We're gonna increment the J if the needle at index J is equal to the haystack at index I. And then if J is equal to the needle size, meaning that we reach the end of the needle and all the characters in needle and haystack are the same, we're going to return the position of the first occurrence. So the position would be I minus J plus 1. Nice, but now, as we spoke about the first part of this algorithm, we need to reset the J pointer if the needle at index J is not equal to the haystack at index I. And if that's the case, we're going to have a look at the context that we built before and update the J index. And if we iterate through the haystack and we couldn't find the solution, we're going to return -1. So now let's run the... Okay, so we run the solution and let's submit it. Okay, the solution is accepted. To recall the Knuth-Morris-Pratt algorithm, remember that we would build a prefix-suffix array based on the needle. We fill it with the length of the substring that is a prefix but also a suffix of the needle. Then we want to iterate over the haystack, and when we find the mismatch, we make a smart decision based on the information in our prefix array and compare the current haystack character with the next needle character after some prefix. That's it for today. Let me know in the comment section if you've ever encountered such a problem and if you've ever been asked to implement Knuth-Morris-Pratt algorithm. Anyway, thank you for watching this video and have a nice day.